Something strange is happening in deep space. Not something small, not something confusing, but something that may challenge everything we thought we understood about the universe itself. And it all comes from the most powerful telescope ever built, the James Webb Space Telescope. In the last few years, it has been sending back images and data from the farthest reaches of space, places so distant that we are literally looking back in time. But recently, scientists noticed something that stopped them cold. Something that doesn't fit, something that shouldn't exist, at least not according to our current understanding of physics. And that is where this story begins. Because if these findings are correct, then we may not just be discovering new things about the universe. We may be discovering that our model of the universe itself is incomplete, or even wrong. Now, before we go deeper, here's the real question scientists are asking. How can something billions of light years away look so wrong? The James Webb Space Telescope was designed for one mission: to look deeper into space than anything before it. It can see galaxies that formed just a few 100 million years after the Big Bang. That means we are not just looking at space, we are looking at the early history of everything. But when researchers started analyzing early galaxy formations, they noticed something unexpected. Galaxies that, according to theory, should not have existed yet. Some of them appear too large, too structured, and too mature for their age in the universe. In simple terms, they look like fully developed cities, when they should only be small villages. And that creates a serious problem, because according to the standard model of cosmology, galaxies take billions of years to grow into the size and structure we see today. Gravity slowly pulls gas and dust together, stars form over time, and galaxies gradually evolve. But James Webb is showing something very different. It's showing massive galaxies, appearing far too early in cosmic history. And that raises a disturbing possibility. Either our timeline of the universe is wrong, or something is happening that we do not yet understand. Scientists first thought it might be a measurement error. After all, when you are observing objects billions of light years away, small mistakes can create big misunderstandings. But then more data came in, and instead of one or two strange galaxies, there were many, too many to ignore. Some of them are so massive that they should not have had enough time to form under known physics. And yet, there they are, clearly visible in James Webb's deep field images. At this point, researchers started asking a bold question. Are we misunderstanding how fast the early universe evolved? Or even more extreme, are the laws of physics different in the early universe? That idea alone makes many scientists uncomfortable, because physics is supposed to be universal. The same rules that apply here on Earth should apply everywhere in the cosmos. But what if they don't? What if something is missing from our equations? Now, to be clear, no one is claiming that the universe is fake or that reality itself is broken. But scientists are definitely saying something important. Our current models may not be complete, and that is a big deal. Because if our models are incomplete, it means there is more to discover than we ever imagined. And James Webb might be the tool that finally shows us that gap. But the mystery doesn't stop with galaxies. There is another strange pattern emerging in the data, something even harder to explain, and it might suggest that the problem is not just about galaxies forming too fast. It might suggest something deeper about time, distance, and how we interpret light from the early universe. In the next part, we will go deeper into what exactly James Webb is seeing, and why some scientists are beginning to question whether we truly understand cosmic history at all. Because what comes next may be even more disturbing than galaxies that should not exist. We talked about something unsettling, galaxies appearing too early, too big, and too developed for the young universe they are supposed to exist in. But the mystery doesn't stop there. Because once scientists started digging deeper into James Webb's data, they realized something even more confusing. It wasn't just that early galaxies looked too advanced. It was that they looked impossible under our current timeline of cosmic evolution. To understand why this matters, we need to slow down for a moment and think about what we actually believe about the universe. According to the standard model of cosmology, the universe began with the Big Bang about 13.8 billion years ago. After that, matter started spreading out, cooling down, and slowly forming the first atoms. Then, over hundreds of millions of years, gravity began pulling gas and dust together. Stars formed, then clusters of stars, then galaxies. It was a slow, steady process, a cosmic evolution that took time. But James Webb is showing something very different in the early universe. It is revealing galaxies that seem too bright, too structured, and too chemically evolved for their age. And that creates a serious problem. Because if these galaxies are real, and not misidentified or miscalculated, then something about our understanding of early cosmic development is incomplete. Scientists initially tried to explain it in the simplest way possible. Maybe the distance estimates were wrong. Maybe the light was being misinterpreted. Maybe gravitational lensing was distorting what we see. These are normal possibilities in astronomy, because when you are observing objects so far away, even small errors can create huge differences in interpretation. But as more observations came in from different regions of the sky, the pattern stayed the same. Early galaxies were still showing up as too massive, too soon. And that is when things started to get uncomfortable in the scientific community. Because this wasn't just one anomaly. It was a pattern. And patterns are what scientists take seriously. Now, here's where things get even more interesting. Some of these early galaxies don't just appear large. They appear organized. They show structures like spiral arms and dense galactic cores that, according to existing models, should take billions of years to fully develop. But James Webb is seeing hints of those structures in a universe that is less than 1 billion years old. So the question becomes unavoidable. How did they form so fast? There are only a few possible explanations, and none of them are simple. One idea is that galaxy formation in the early universe was much faster than we thought. That gravity worked more efficiently, pulling matter together at a speed we never accounted for. But that raises another question. Why would gravity behave differently in the early universe? And if it didn't, then something else must be missing. Another possibility is that we are misreading the brightness and distance of these galaxies. Maybe some of them are closer than we think, or their light has been affected in ways we don't fully understand yet. But even after correcting for these possibilities, many of the observations still hold up. Which brings us to a more uncomfortable idea. Maybe our models of how the universe evolved are incomplete at a fundamental level. Not wrong, but incomplete. And there is a big difference between those two ideas, because incomplete models mean there are hidden variables, unknown physics, or missing pieces that we have not discovered yet. And James Webb may be exposing exactly that. Now, there is another layer to this mystery that scientists are quietly paying attention to. It involves something called redshift. Redshift is how we measure how far away a galaxy is, based on how much its light has been stretched as the universe expands. The farther away an object is, the more its light shifts toward the red end of the spectrum. It's one of the most important tools in modern astronomy. But what if redshift is telling us something we don't fully understand yet? Some researchers are beginning to wonder whether the relationship between redshift and distance is as straightforward as we assumed. Because if it isn't, then some of these early galaxies might not be where we think they are. And that would completely change the picture. It could mean that the early universe is not what we imagine at all. But even with all these uncertainties, one thing is clear. James Webb is not just giving us clearer images. It is forcing us to question the foundation of cosmic history itself. And the deeper we look, the more questions appear. In the next part, we will explore what scientists are saying about these findings behind closed doors, and why some of them believe we may be standing at the edge of a major shift in cosmology. Because if the current models are wrong, even slightly, then everything we think we know about the universe could change. By now, the mystery is getting harder to ignore. James Webb is showing us a universe that doesn't seem to match the universe we thought we understood. And while public discussions often focus on strange galaxies or early structures, inside the scientific community, the conversation is becoming more serious. Because this isn't just about one or two unusual observations anymore. It's about whether the entire framework of cosmic history needs adjustment. Now, scientists don't jump to dramatic conclusions easily. In fact, the first response to these findings was skepticism. Many researchers assumed there must be an error in interpretation. That is always the safest explanation when new data conflicts with established models. But as more independent teams analyzed James Webb's observations, the same results kept appearing. Early galaxies that are brighter, denser, and more massive than expected. And the key issue isn't just that they exist, it's when they exist. They are appearing at a time when the universe should still be in its early developmental stages. So the question becomes unavoidable. Are we missing a major piece of cosmic evolution? To understand why this is such a big deal, imagine if you found fully built cities in historical records where only small settlements should exist. That is essentially what James Webb is revealing on a cosmic scale. Now, one of the most discussed possibilities among scientists is something called accelerated structure formation. This idea suggests that in the early universe, matter may have clumped together much faster than our current simulations predict. In computer models of the universe, galaxies form gradually over long periods of time. But those models are based on assumptions about dark matter, gravity, and the behavior of gas in the early cosmos. If even one of those assumptions is slightly off, the entire timeline could shift. And that is exactly what some researchers are now considering. Because James Webb is not just showing isolated cases, it is showing a statistical pattern. Too many early galaxies appear too advanced. But there is another layer to this debate that is even more controversial. Some scientists are beginning to ask whether we fully understand the role of dark matter in early galaxy formation. Dark matter is invisible. We cannot see it or directly measure it. We only infer its existence based on gravitational effects. It is believed to be the scaffolding that helped galaxies form in the first place. But what if its behavior in the early universe was different than we assume? Even small changes in dark matter interactions could dramatically speed up galaxy formation. That could explain why massive structures appear so early. But here's the problem. We don't have direct evidence for how dark matter behaves in those early epochs. We only have models. And models are only as good as the assumptions they are built on. Now, while this debate continues, another group of scientists is focusing on something else entirely. They are looking at the possibility that the issue is not with the galaxies themselves, but with how we interpret the light coming from them. Because everything we know about distant galaxies comes from light, and that light travels across billions of years of expanding space before it reaches our telescopes. So if anything affects that light along the way, cosmic dust, gravitational effects, or unknown interactions, it could distort our measurements, even slightly. And when you are dealing with the early universe, even a small distortion can lead to a huge misinterpretation. This is why some researchers are urging caution. They are not rejecting the James Webb data, but they are saying we may not fully understand how to interpret it yet. And that is a crucial distinction. Because in science, data alone is not enough. Interpretation is everything. Now here is where things become even more interesting. Some theoretical physicists are beginning to explore more unconventional ideas, not because they believe them definitively, but because the data is forcing them to consider possibilities that were previously ignored. Ideas like variations in fundamental constants in the early universe, or unknown physics operating during the first billion years after the Big Bang. These are not mainstream conclusions, but they are being discussed more openly than before. And that alone shows how significant James Webb's observations have become. Because when established models start showing cracks, even small ones, scientists are forced to look deeper. And sometimes, that leads to major breakthroughs. Other times, it leads to revisions of long-held theories. But in either case, it means one thing. We are learning something new, and James Webb is at the center of it. Now, despite all this uncertainty, there is one important point that scientists agree on. Nothing about these findings suggests the universe is wrong or impossible. Instead, they suggest that our understanding is still evolving, that we are seeing further than ever before, and realizing that our old explanations may not be enough anymore. And that realization is both exciting and unsettling at the same time, because the deeper we look into the universe, the more it seems to surprise us. In the next part, we will explore the most controversial ideas being discussed in theoretical physics right now. Ideas that push the boundaries of what we think is possible, and why some scientists believe James Webb might not just be revealing the universe, but rewriting how we understand reality itself. At this point in the story, the questions are no longer small. We are no longer just asking why galaxies formed early, or why some appear too massive for their age. Now the deeper question is this: what if the problem is not just what we are seeing, but how we understand reality itself? That might sound extreme, but in theoretical physics, even the most unusual ideas are explored when data starts pushing against established limits. And James Webb's observations are doing exactly that. Because the more scientists analyze the early universe, the more they realize something important. The standard model of cosmology works extremely well, until it doesn't. It explains the evolution of the universe from a fraction of a second after the Big Bang up to the large-scale structure we see today. But the earliest galaxies observed by James Webb are stretching that model in ways that are difficult to ignore. So now, some physicists are exploring more radical possibilities, not as facts, but as questions worth considering. One of those ideas involves the possibility that the early universe evolved under slightly different physical conditions than today. This does not mean the laws of physics changed completely, but even tiny variations in fundamental constants, like the strength of gravity or the rate of expansion, could drastically alter how quickly structures formed. If gravity was even slightly stronger in the early universe, matter would clump together faster. If cooling processes in gas clouds were more efficient, stars could form earlier. And if dark matter interacted differently than we assume, galaxy formation could accelerate dramatically. Each of these possibilities, on its own, could help explain what James Webb is seeing. But there is a problem. We don't have direct evidence that any of these constants changed. We only have the observations that are challenging our current assumptions. And that brings us to another controversial idea being discussed quietly among some researchers. What if the early universe was not as uniform as we think? The standard model assumes that after the Big Bang, matter was distributed relatively evenly, with tiny fluctuations that eventually grew into galaxies. But what if those fluctuations were larger than expected? Or what if there were regions where matter was already more concentrated than our models allow? That could also explain why some galaxies appear so developed so early. But again, this leads to another question. Why would those regions exist in the first place? Now, while these debates continue, another group of researchers is exploring something even more unusual. They are questioning whether our interpretation of distance itself could be introducing bias into our conclusions. Because when we observe the early universe, we are not seeing galaxies as they are today. We are seeing them as they were billions of years ago, based on the light that has traveled across expanding space. That light carries information, but it also carries distortion. The universe is not static. It is expanding. It is evolving. And that means light is stretched, shifted, and sometimes altered in ways that require complex interpretation. So the question becomes, are we absolutely certain that we are placing these galaxies at the correct point in cosmic history? Even small errors in redshift interpretation can lead to huge differences in estimated age and size. And if those calculations are off even slightly, the entire narrative of early galaxy formation could shift. But even after accounting for these uncertainties, many of the James Webb observations still remain difficult to explain, which is why the scientific community is not reaching a single conclusion. Instead, it is entering a phase of active debate. And that is how science progresses. Now, here is where things become even more fascinating. Some theoretical physicists are beginning to connect these observations with deeper questions about the nature of space and time itself. There are models, still highly speculative, that suggest space-time may not be perfectly smooth at the smallest scales. Instead, it might have a kind of structure or texture that we cannot directly observe. If true, that could affect how matter behaves in the early universe. It could influence how quickly gravity acts over long distances, and it could even impact how light travels across cosmic time. These ideas are not mainstream conclusions, but they are being discussed more openly because the data is forcing scientists to think beyond traditional explanations. Now, despite all these theories, one thing remains clear. No one is claiming that James Webb has shown that we are living in a wrong universe. That phrase is more of a dramatic interpretation than a scientific conclusion. What scientists are actually saying is more careful, but still very important. They are saying that our current models may not fully explain what we are seeing, and that is a major moment in science. Because whenever observations outpace theory, something new eventually emerges. Sometimes it is a refinement of existing ideas. Sometimes it is a completely new framework. But it always leads to deeper understanding. And James Webb is pushing us into exactly that kind of moment. A moment where the universe is not breaking the rules, but revealing that we may not know all the rules yet. In the final part, we will look at what this could mean for the future of cosmology, and why some scientists believe we may be entering a new era of discovery, one that could reshape how we understand the origin, structure, and future of the universe itself. As we reach the final part of this story, one thing becomes clear. The James Webb Space Telescope is not just giving us better pictures of space, it is forcing us to rethink how we understand the universe itself. Because the deeper scientists look, the more they realize that the early universe may not fit neatly into the story we have been telling for decades. And that is where the real importance of this discovery lies. Not in proving that the universe is wrong or impossible, but in revealing that our understanding of it may still be incomplete. For a long time, cosmology has been built on a strong foundation. The Big Bang model explains the expansion of the universe. Dark matter helps explain structure formation. Dark energy explains accelerated expansion. Together, these ideas form the framework of modern astronomy. And for many years, this framework worked extremely well. It matched observations, it made predictions, and it helped us understand everything from galaxy formation to the cosmic microwave background. But now, James Webb is pushing that framework into a new test. Because when we look deeper into the early universe, we are not just seeing faint, primitive structures. We are seeing complex, massive galaxies that appear earlier than expected. And while each individual case might be explainable on its own, the overall pattern is harder to ignore. So what happens next? In science, there are usually 3 stages when something like this happens. First, researchers question the data. Second, they test the assumptions. And third, if the pattern remains, they begin adjusting the models. Right now, cosmology is moving between stage 2 and stage 3. Scientists are carefully checking every assumption behind distance measurements, galaxy mass estimates, and early universe simulations. They are rerunning models, they are refining calculations, and they are comparing data across different telescopes and surveys. Because extraordinary claims do not require extraordinary conclusions, they require extraordinary verification. And so far, James Webb's data is holding up under intense scrutiny. Which means scientists are now seriously considering that something in the early universe may not be fully understood yet. But what does that actually mean for the future? It means we may be entering a new era of cosmology. An era where instead of confirming what we already know, we start discovering what we don't know. And that is where science becomes truly powerful. Because every major shift in our understanding of the universe has come from moments like this. When something doesn't fit, when something challenges expectations, when data forces theory to evolve. We saw it when we learned that the universe is expanding. We saw it when we discovered dark matter. We saw it again when dark energy was introduced. And now, we may be seeing the beginning of another shift. Not because everything we know is wrong, but because everything we know might only be part of the story. Some scientists believe that James Webb could eventually help refine the timeline of galaxy formation. Others think it may improve our understanding of dark matter behavior in the early universe. And some even suggest it could lead to entirely new physics that we have not yet discovered. But there is also a more grounded perspective. Many researchers emphasize that science is a process of gradual refinement, not sudden collapse. In other words, the universe is not changing. Our understanding is. And that distinction is important, because while the phrase, "this isn't our universe," sounds dramatic, the reality is more subtle and more interesting. We are looking at the same universe we have always had. We are just seeing it more clearly than ever before. And sometimes, clearer vision reveals complexity we did not expect. Now, as we bring this story to a close, there is one final thought to consider. Every time humanity has built a more powerful telescope, we have discovered something unexpected, something that expanded our understanding, something that changed our perspective. From Galileo's first observations of Jupiter's moons, to Hubble's discovery of an expanding universe, to James Webb's deep field images today, each step has brought us closer to understanding our place in the cosmos. And yet, each step has also shown us how much more there is to learn. So maybe the real discovery here is not that we are living in a different universe, but that the universe is far more complex, ancient, and surprising than we ever imagined. And James Webb is only just beginning to reveal that truth. Because the more we look into the darkness, the more the universe seems to answer back. Not with simple explanations, but with deeper questions. And those questions are what will guide the next generation of discovery. For now, scientists continue to study, debate, and refine what James Webb has shown us. And somewhere out there, billions of light years away, ancient galaxies continue to shine, holding secrets that may one day rewrite everything we think we know about the cosmos.